Alright, let's take a look at, this is now chapter 8, starting to deal with rational expressions, but we still need factoring in order to deal with these. This is a rational expression, which we also can think of as a polynomial fraction, following all the rules of fractions and all the rules of polynomials. To write this expression in lowest terms, we would need to see if we can factor these trinomials, and then if there are any common factors that we could cancel, removing factors of 1. So I would look at this trinomial and I would say, since the leading coefficient is 1, maybe we could quickly factor this by guessing the correct factors and not having to use a table. Alright, so we're looking for factors that multiply for 14 and add for negative 9. So they have to multiply positive and add negative. If they multiply positive, they have to be the same sign, so they must be two negatives. And then what numbers multiply for 14 and add for 9? About 2 and 7. Alright, now check that quickly. Z squared, negative 7z, negative 2z, add for negative 9z, and these two multiply for positive 14. Good factoring. Okay, so now let's see if we can do the same thing for this denominator trinomial. Again, since the leading coefficient is 1, let's see if we can guess our way to the correct factors without having to make a table. Alright, so this time we want to multiply for negative 18 and add for positive 7. If we multiply negative, then we have to have one of each sign. Okay, we have to have different signs. And let's see, multiplying for negative 18, add for positive 7. I believe 9 and 2 will work, and we want a positive in the middle, so let's make the positive the larger 9 and the negative the smaller 2. And now let's check that. Z squared minus 2z plus 9z gives us the correct term in the middle and multiplies for negative 18 on the end. Now that we see that, now that we have our trinomials factored, we can remove any factors of 1, which means a matching factor in the numerator and denominator cancel to 1. Okay, matching factors cancel to 1. That leaves us a numerator, z minus 7. That's the only binomial, that's the only factor left, so we don't need the parentheses in the numerator. Same thing in the denominator, one factor left, z plus 9. We don't need the parentheses. Now, remember, you're going to resist the urge to cancel the z's there because they're not factors, they're now terms. If they didn't cancel in the parentheses here, they don't cancel when you remove the parentheses. All right, let's take a look at multiply and simplify. Remember, this is more polynomial fractions, okay? Rational expressions, polynomial fractions. So in order to multiply and simplify fractions, if we write things in factored form first, we may be able to cancel before we multiply and get a lowest term result, a simplified result. So this is rather long, so let's start our factoring below here. First numerator is a trinomial. Let's see if we can factor it without a table. Trinomial might have come from a binomial times a binomial. So let's put the z's in for z squared, and we want to multiply for negative 27 and add for positive 6. I believe those factors would be positive 9 and negative 3. Okay, let's go ahead and factor the denominator. Again, I believe we can do this without a table. Z's for z squared, and then multiply for negative 24, add for positive 5. Let's try positive 8, negative 3. That multiplies correctly and adds correctly. Alright, now since we're multiplying, we can go ahead and put all of our factors together here. So now how does this numerator factor? Well, I believe it's two more binomials. Z times z for z squared, multiply for negative 32, add for negative 4. Let's try negative 8 positive 4. That will multiply for negative 32 and add for negative 4z. Denominator factored, z's for z squared, multiply for positive 36, add for positive 13. How about plus 9 plus 4? That multiplies correctly and it adds correctly. So now everything is factored. We're showing our multiplication with everything factored. Now we can cancel any factors of 1, remove any factors of 1. So I look at z plus 9 and I see a common z plus 9 down here. So that's removing a factor of 1. It's also called canceling. Here's a z minus 3 and a z minus 3. That's a factor of 1. Here's a z plus 4 and a z plus 4. That's a factor of 1. This is a z minus 8 and a z plus 8. So those are not the same factor, so those do not cancel. So now the only factor we have remaining in the numerator is z minus 8. The only factor we have remaining in the denominator is z plus 8. And remember, we don't cancel anything else here. We don't cancel z's or 8's because these are now terms, not factors. Okay, if they didn't cancel in the parentheses, they don't cancel when we remove the parentheses. Let's do a divide and simplify. This will still, remember, we're still needing to practice we still need our factoring skills here. Division is just like multiplication after we do what? After we change to multiply by the reciprocal. That means we will trade places with the numerator and denominator, but we'll factor as we go. Alright, so there's a lot of factoring here, a lot of good practice for factoring. X cubed plus 27, that's a binomial. And you should recognize it as a sum of cubes. Now, how does a sum of cubes factor? Well, into a binomial and a trinomial. Okay? So our binomial is, what do we cube to get x cubed? X. What do we cube to get 27? 3. And then for the trinomial, we square the x, we multiply the 2 together, and we square the 3. And then we place our signs, the same sign, opposite, and always positive. So we have factored the first numerator. Let's go ahead and factor the denominator. It's a binomial. Square, it's a difference of squares. Okay, so difference of squares factors into a sum and a difference. X's for x squared. What do we square to get 9? 3. And that gives us a sum x plus 3, a difference x minus 3, which we know will FOIL to give us only 2 terms. Okay, middle terms will cancel. Now we can go ahead and write this as one long multiplication. Remember, we're going to change this to multiply. So we are going to factor these if possible, but we're going to trade places. So the denominator, if it factors, we're going to move those factors to the numerator. I believe x squared minus x minus 6 factors. X is for x squared. And multiplying for negative 6 and adding for negative 1. Negative 3 and positive 2 ought to do that. Check that and make sure. And then the numerator, if it factors, will go to the denominator. They'll go to the denominator whether it factors or not. So what we're looking for, if we're hoping that it might factor, but x squared minus 3x plus 9, there are no factors that multiply for positive 9 and add for negative 3. You can look for a while, you will discover there are none. So that doesn't factor, so we have to write it just like it is, x squared minus 3x plus 9. Now we can look for factors of 1 to remove. Are there any matching factors in the numerator and denominator? Here's an x plus 3 and an x plus 3. Here's an x minus 3 and an x minus 3. And our trinomial here that did not factor happens to match this other factor here in the numerator, doesn't it? X squared minus 3x plus 9. They're matching factors. x plus 2 does not have anything to cancel with, no matching factor. And so we have x plus 2 in the numerator, all 1's in the denominator, don't we? These were factors of 1. All 1's, only 1's in the denominator. And to simplify that, we wouldn't write a denominator of 1. We would simply write the x plus 2.